Um, both of them are molds. One is a cavity block, cavity insert block for a mold, and that's what you see on the screen right here. So if you look in the top right picture up here, and also the cross section down below, we just pointed out the types of areas that we're going to be required to machine in this job. So we basically obviously have the cavity itself, which has a contoured shape, a standard cross-section shape that's revolved. And we also have a number of machinable areas such as bosses. We got some pockets. And if you look at the cross-section, that gives you a good idea of what we're going to have to contend with in this and machine programming this part. And then on the right side, you see the green surface. We're calling that a masking surface. You can call it whatever you want, a reference surface or a guide surface or whatever you want to call it. Basically, in the process of reviewing your model and what your approach is going to be to machining this, decided that we didn't want the tool to go into these pocket areas at the top, for finishing. And we don't want the tool to roll over these edges. We want to make those edges nice and sharp. So we add we cut a cross section of the part, revolve it around to create this masking surface here, where you see there's no interruptions other than the bosses sticking out. There's no interruptions in that surface.
And the reason we call that a masking surface is because we want to basically mask some of the features underneath the surface or protect the features from being machined. So we're basically going to be going through stages of machining, and that's the main reason we're calling that the masking surface.
Yes, if you're familiar with our products, if a surface is visible and you're running a 3-axis operation, it will enter into the calculation of the tool path. So if you don't want something to be machined, you want to mask it or turn it off. Some people just have different layers that they have on and off depending on whether they're which operation they're working on. Okay, so let's go to the next slide. Here, this slide, it just goes over how we're going to approach programming this part. If you look at the machining job here on the left, we're going to start out with a couple of roughing operations. And you see the note on this is with mask on. So we're going to cut a section and rotate that surface around to create our masking surface. I'll show you how to do that. So we'll have the masking surface on for both of the roughing and a horizontal finishing operation. And then we'll also do a spiral and a radial finishing operations. And then we're going to wrap it up with the profiling around the perimeter. We're going to pocket out the pockets, and actually the areas on top of these bosses. I've decided to treat that as a pocket, which turned out pretty well, rather than a face. And then we also included you see, and we got what we call a mop set. We got 2 mop sets, one at the top, which says standard, and one at the bottom, which says pro. So we're going to be going through the standard operations and the standard configuration to program this. We're going to look at the pro. We have one operation that if you're running the pro, you can use that operation, but we're just going to look at it. It's already programmed. And here's the tools down below that we're going to be using: flat end mills, ball mills, etc., in a 1/4 radius mill. Because that's a good point. Because when I show you the model, there's some fillet radiuses in these areas. Like this first slip, there's a radius in the corner that we don't want to machine out. Okay, so we have a 1/4 radius mill that we're going to use for finishing those areas, and there's fillets, in this area around here as well. Okay.